Hi, so today we are going to talk about collision theory, but before I proceed, I hope you remember that in the last few videos we have been talking about the rate law and integrated rate equation, and both of these theories told you about how the rate of the reaction relates with the substrate concentration and how the substrate concentration changes with time, right? So, these laws told you how the reaction progresses, whereas collision theory gives you a mechanism for a reaction. How do you think a reaction occurs? The collision theory is based on the kinetic theory of molecules, and that implies that molecules have a certain energy associated with their movement. So when there are two molecules that we are talking about, atoms or molecules, let's just say reacting species, when there are two reacting species that are in a reaction, they must collide together so that they can yield a product. Now, collision theory says there are three things that affect if and or how the reaction proceeds. The three things are number of collisions. As you can imagine, if there are more collisions happening, the rate of reaction will be more. So you increase the pressure, you get more reaction. The second thing is the orientation of these collisions. So the collisions must happen in a proper orientation of the molecules, because we understand that the electrons are distributed around the molecule in a perfect geometry, right? So third thing that we need to be bothered about is the energy of these collisions. Now let us talk more about this by this graph. So if this graph here on the x-axis, we represent the reaction progress, and on the y-axis, we represent the potential energy of the molecules. Now these dotted lines represent the initial, so the first dotted line represents the energy with the reactant, whereas the final line represents the energy with the products. Now, let us take an example here, CH3NC. Now, in this particular reaction, what we intend to do is just change or rotate the bonds in such a way. But for such rotation to happen, the collision must happen with enough energy. The minimum energy that is required to do that is called the activation energy, which is nothing but the difference of the energy of the reactants and this energy of that final state, that's called a transition state, over which the reaction can occur. So in this particular example, we can see that the CN bond has just been twisted enough by the collision so that it can finally be inverted over and we can have CH3CN instead, right? So as we can see, the collision theory explains the three important aspects of the collision that must happen for the reaction to take place. The number of collisions, which is determined by pressure factors such as pressure or temperature, because you remember increasing temperature increases the kinetic energy and hence the number of collisions that are happening. So both pressure and temperature can increase number of collisions. The second could be the orientation of these collisions that's happening. It has to happen at a certain direction so that the products can be formed. And the third is the energy of these collisions that are happening. And for that, we define a term called EA, that's also termed as the activation energy, which is the energy difference between the energy of the reactants and of the transition state, the state after which the product can be formed. So this is the summary of the collision theory. Now, how does temperature factor into these collisions and into the activation energy is very much explained by the Arrhenius equation, which we'll be talking about in the next video.
We hope you like this video. Press subscribe, thumbs up, and stay geekly.